Hello, my dear friends. Welcome back to my channel. Today, we'll be reading about fluid mechanics. A fluid is a substance which conforms continuously under the action of shearing force. If a fluid is at rest, there can be no shearing force acting, and therefore, all forces in the fluid must be perpendicular to the planes in which they act. Fluid is of three types: statics, kinematics, and dynamics. Statics deals with fluid at rest, kinematics deals with velocities and acceleration. They do not consider forces or energy. On the other hand, dynamics deals with relations between velocities, accelerations, and the forces exerted. Mean free path is to characteristic length of flow should be less than 1. Mean free path is statistical average distance which molecules of the same fluid travel between collisions. Ideal fluid: non-viscous, frictionless and incompressible. It does not exist in reality. Does not offer shear resistance when fluid is in motion. Properties of fluids: mass density. It is mass per unit volume. Its unit is kg per meter cube, ml-3. It is an absolute quantity, that is, it does not change with location. Mass density is directly proportional to pressure. Mass density of water is 1000 kg per meter cube. Mercury is 13.4546 kg per meter cube. Air is 1.23 kg per meter cube. Paraffin is 800 kg per meter cube. Specific weight. Specific weight of a substance is weight of a substance per unit volume. Newton per meter cube. ml-2 t-2. It is not an absolute quantity. Specific weight of water is 1000 kg per meter cube into 9.81 meter per second square, that is 9810 Newton per meter square per meter cube. Specific volume: volume occupied by a unit mass of fluid is called specific volume. It is inversely proportional to rho. Its unit is meter cube per kg. It is applied for gases. Next comes specific gravity, G. It is the ratio of specific weight of a fluid is to specific weight of standard fluid. For liquids, standard fluid is water at 4 degrees Celsius, and for gases, standard fluid is hydrogen or air. Specific gravity of water is taken as 1 and mercury is taken as 13.6. Viscosity: it is measure of resistance to shear or angular deformation. By virtue of it, it offers resistance to the movement of one layer of fluid over the adjacent layer. Newton's law of viscosity: it shows shear stress is directly proportional to angular deformation. That is, F over A is directly proportional to dE over dt, where F is the force required to move the surface and A is the area. Tau over mu is equal to du over dy, where du over dy is velocity gradient, tau is shear stress, and mu is dynamic viscosity. According to Newton's law of viscosity, for a given shear stress acting on a fluid, that is tau, the rate at which fluid deforms, that is nu over y, is inversely proportional to viscosity. Newtonian fluid. Newtonian fluid are those fluid which obey Newton's law of viscosity. They have constant viscosity, that is, their viscosity is independent of shear stresses. There is linear relationship between shear stress and resulting rate of deformation. Examples of Newtonian's fluid are air, water, light oils, and gasoline. Non-Newtonian fluids. They do not follow Newton's law. Relationship between shear stress and velocity gradient is given by tau equals to A du over dy raised power n plus b. This is a graph. Examples of dilatant non-Newtonian fluids are butter, quicksand, pseudoplastic, blood, paper, pulp, rubber, clay, milk, cement, suspension paint, Bingham plastic, sewage, sludge, drilling mud, thixotropic fluids, printer's ink, lipstick. Kinematic viscosity mu is given by dynamic viscosity is to mass density, that is nu over rho. Its SI unit is meter cube per second or centimeter square per second or Stokes. Its dimensional formula is L square T minus 1. Dynamic viscosity. Its unit is Newton second per meter square or kg per meter second or poise, which is equals to 1 poise equals to 1 dyne second per centimeter square. Its dimensional formula is given by ml minus 1 t minus 1. In gases, the viscosity is dominated by molecular collisions, which increases with temperature, so does their viscosity. In liquids, the viscosity is dominated by intermolecular cohesive forces, which reduces with temperature, and so does their viscosity. Vapor pressure. When the air above the surface of liquid is saturated with liquid vapor molecules, then the pressure exerted on liquid surface is called vapor pressure. Vapor pressure is directly proportional to temperature. Cavitation. Cavitation occurs in flow systems. It is dissolved gases or vapor bubbles carried into a region of high pressure, and their subsequent collapse gives rise to high pressure. It leads to noise, vibrations, and erosion. It occurs in turbine runners, pump impellers, hydraulic structures like spillway and sluice gates, and ship propellers. Compressibility. Change in volume or density due to change in pressure. It is inversely proportional to bulk modulus. Coefficient of compressibility is given by beta is equal to 1 over k, 1 over bulk modulus. Liquids have high values of bulk modulus. Liquids are considered as practically incompressible. Value of K for water is 2200 mn per meter square. Velocity of sound C equals to under root of K over rho. Bulk modulus of gases is low, hence highly compressible. E of air is equals to 100 into 10 raised by 3 Newton per meter square. Flow of air in ventilating system is considered incompressible. Match number M equals to V over C. It should be, if it is greater than 1, then it is compressible. Surface tension. Surface energy per unit area of interface. Its unit is Newton per meter and its dimensional formula is mt minus 2. It is due to the cohesion. Temperature is inversely proportional to surface tension. Capillarity. Rise or fall of liquid due to cohesion and adhesion. Centimeter or mm of liquids. It is measured in centimeter or mm of liquid. Capillary rise if adhesion is greater than cohesion, then capillary rise takes place. Theta is 0 for water and glass, and theta is 130 for mercury and glass. Capillary action only features in pipes of less than 10 mm diameter. Here is the quantities with dimension formulas and units. You can learn them by yourself. A fluid is one which can be defined as a substance that can deform indefinitely under the action of smallest shear force. Thank you.